This is Mrs. A of Math A Matic. Today you're going to learn how to solve quadratic inequalities. So first, here are quadratic inequalities in standard form. So I have here ax squared plus bx plus c is greater than 0, ax squared plus bx plus c less than 0, ax squared plus bx plus c greater than or equal to 0, and ax squared plus bx plus c is less than or equal to 0. So take note of this. First, you need to identify if the highest exponent of x is 2. And then, the inequality sign instead of equal sign. Okay, now how to solve quadratic inequalities. So here's the steps. First, express the inequality as ax squared plus bx plus c is equal to 0 and solve for x. So whatever the inequality sign here, you need to change it to equal sign. Then, locate the values of x on the number line. Then, divide the number line into 3 parts. Next, choose a number in each part as test point and substitute each point in the inequality. If the results of this test point is true, then that part belongs to the solution set. If it is false, then it's not part of the solution set. Example here, x squared minus 9x plus 18 less than 0. So what I'm gonna do is change this to equal sign. Then I have now x squared minus 9x plus 18 is equal to 0, and I'm going to solve for the value of x by factoring. So factoring trinomials, if you don't know how to factor trinomials or if you have problem, I have video on this so you can watch. So here I'm just going to think of two factors of positive 18 that if I'm going to add is equal to negative 9. So that is negative 3 and negative 6. That is positive 18. Negative 3 plus negative 6, that is negative 9. Then I'm going to equate to 0 each factor. X minus 3 is equal to 0. X minus 6 is equal to 0. Then solve for x. X is 3. X is equal to 6. Simply this one, eliminate this. So you can add positive 3 here on the other side. Same here, positive 6 here. Or simply transpose this on the other side, and if it's negative, it becomes positive. Now, locate these two values of x on the number line. No need for you to actually write all the integers on the number line, just to save your time. So let's just have 3 and 6. But make sure that you know how to place those numbers on the number line. The larger number is always on the right side. Okay, now, here, since the arrowhead is continuous here to the right, that is the positive infinity. And to the left, that is negative infinity. Now, you notice that here we have now from 3 going to negative infinity. Let us just name that as 1 region. And then from 3 to 6, that is another part here, and that is 2. Name that one as 2, just for reference. Then here, from 6 going to positive infinity, let's have that 3. Okay, so now this is now the given. So we're going to test the point. So first, in this first one here, you know that this is 3 going to negative infinity. So we have a lot of integers here. We have 2, 1, 0, then negative up to negative infinity. So you can choose any of those numbers, but make sure to choose one that is easy to manipulate or to add or multiply. So let's choose, for the first part, let's choose 2. X is 2. And then simply you're just going to substitute this x to x here and here. So that is now 2 squared minus 9 times 2 plus 18 less than 0. So 2 squared, that is 4. Negative 9 times 2, that is negative 18 plus 18. And then negative 14 plus 18 less than 0, and that is 4 less than 0. Is 4 less than 0? Is it correct? No, so it's false. Now, you will learn later why is it true or false. We need that. Okay, let's have first for the second part here. So that is between 3 and 6. So we can choose any number here, 3. So we can choose 4 or 5. So let's have 4. So again, substitute x by 4. Here is 4. And 4 squared, and that is 16 minus 36 plus 18 less than 0. 16 minus 36, that is negative 20 plus 18 less than 0. So negative 2 is less than 0, which is true. Okay, third part here, from 6 to positive infinity, we can choose 7. And that is 7 squared minus 9 times 7 plus 18 less than 0. So 49 minus 63 plus 18 less than 0. So 49 minus 63, that is negative 14 plus 18 less than 0. So we have 4 less than 0, which is false. Now, here we have here negative 2 less than 0, which is true. Which means that the solution set of this example is on this part of the number line or region. Okay? So how are we going to write that? Okay. Now, you notice that I have here less than. So if it's less than or greater than, you are going to have here an open circle, hollow circle. Okay? It means that 3 is not included. 6 is not included. Okay, so how are we going to write the solution set in interval notation? So in interval notation, so we have 3 here and open parenthesis, because this open parenthesis means that 3 is not included. And then comma, then 6, then close parenthesis, which means also that 6 is not included. That's how you're going to write. Okay, let's have another one. X squared plus 2x minus 3 greater than 0. Again, I'm going to change that to equal sign. So I have now x squared plus 2x minus 3 is equal to 0. In factored form, I have now x minus 1 times x plus 3 is equal to 0. And I'm going to equate this to 0. And then the other one also, x plus 3 is equal to 0, and solve for x. X is 1, x is negative 3. Then locate these values of x on the number line. So I have the negative 3 and the 1 is there. 1 is greater than negative 3. So it should be on the right side of 3. And then we have here the positive infinity and the other one is the negative infinity. Now, again, that's region, first one, the second one, and the third. So let's have the test point now. Okay, the first part here, from negative 3 going to negative infinity, you know that what are those numbers from here going there? We have negative 3 here, which means we have negative 4, negative 5, negative 6. So let's start with negative 4. Use x equal to negative 4 as our test point. Sorry about that. Okay, so we have here negative 4 squared plus 2 times negative 4 minus 3 greater than 0. So just simply change x to negative 4. So this is negative 4 times negative 4 is positive 16. And then 2 times negative 4, negative 18, minus 3 greater than 0. 16 minus 8 is 8 minus 3 is greater than 0. So we have 5 greater than 0, which is true. Okay, the second part, from here, going here, that is the test point, we can use x is equal to 0. Because here, -3, -2, -1, 0, 1. Okay, because it's easy if you're going to use 0. Simply, x is 0. Then here, x, or 0 squared, 0. 9 times 0, that's 0. So what we have is only -3. -3 is greater than 0, which is not true. What about the last part here, from 1 going to positive infinity? Let's choose x is equal to 2 and substitute x by 2. So 2 squared plus 2 times 2 minus 3 is greater than 0. So 4 plus 4 minus 3 greater than 0. So we have 8 minus 3 greater than 0. 5 is greater than 0, which is true again. Which means that we have two regions as part of the solution set. Again, I'm going to put a open circle here. I mean, not shaded, which means that -3 is not included and +1 is not included also because of greater than. So if greater than or less than, it should be a hollow circle. Now, the part of the solution now is from -3 going to -infinity because this part here is true, and there also because this part 3 here is also true to positive infinity. So what would be our solution is we're just going to combine these two. And that is, we're going to have a union now of two set of values or set notation here. So here, the first one, this is -infinity. The -infinity is always, you're going to use parentheses because it means it's continuous. So open parenthesis here, -infinity, comma, -3, then close parenthesis, which means that -3 is not included, then union. 1, start with 1. So that is open again because this is 1 is not included. Then positive infinity, again, that is parenthesis. Okay, next. We have x squared plus 3x minus 10 is greater than or equal to 0. So again, I'm going to change this one to equal sign, and then I'm going to factor this 1. So what is the two factors of -10? Wherein if you're going to add, the result is 3. So I have here 5 and -2. 5 times -2, -10, +5, minus or plus -2 is +3. And then equate each factor to 0. And then solve for x. X is equal to -5 and x is equal to +2. And then what we're going to do now is locate these two values of x on the number line. So -5 is there and +2 is there. And then we have there the positive infinity and here is the negative infinity. So this is now one part of the number line here. Then we have from -5 to 2 and then we have 2 to positive infinity. So let's have here, look at this. This is now a shaded circle. Why? Because we have here equal sign. It means that -5 and +2 are included. Okay, so let's have the original inequality. X squared plus 3x minus 10 greater than or equal to 0. And we're going to get our test point. In this first part, we have what is the value of x? We have here -5, which means you can choose any values or any integers going to negative infinity. So -5, we can have -6, okay, -7, -8. So if you're going to use negative, 6, you're just simply going to replace x by negative 6, x here by negative 6. So negative 6 squared plus 3 times negative 6 minus 10 is greater than or equal to 0. So this is 36 minus 18 minus 10 greater than or equal to 0. 18 minus 10 greater than or equal to 0. 8 is greater than or equal to 0, which is true. Which means here, that's part of the solution set. Or that region is a solution set. Okay, now, this one. We have negative 5 and we have 2, which means we have 1 here. We're going to choose 1. So it's easy for us to substitute or to manipulate. You can choose negative 4, negative 3, negative 2, negative 1, 0, or 1. Actually, 0 is the best, but I have here x as 1. So I'm going to replace now x by 1. So that is 1 squared plus 3 times 1 minus 10 is equal to or greater than or equal to 0. So that is now 1 squared is 1 plus 3 minus 10 is greater than or equal to 0. So that is now 1 plus 3, that is 4 minus 10, greater than or equal to 0. So negative 6 is greater than or equal to 0, which is false. Which means this is not part of the solution. Okay, what about the last part there? So I have 2 here, which means I can choose any numbers after 2, which is 3, 4, 5, up to positive infinity. So I'm going to choose x is equal to 3. And I'm going to substitute x as 3. So I have now 3 times 3, that is 9, plus 3 times 3, that is again 9, minus 10 is greater than or equal to 0. So that is 18 minus 10 is greater than or equal to 0. 8 is greater than or equal to 0, which is true. Which means this part here is a solution and also here. So again, we're going to combine that to that one. Okay, so the shaded part there. So our solution set in interval notation now is, start here, open parenthesis, negative infinity because it's continuous there. Then, comma, negative 5. And you've seen here I have a close bracket. So bracket here because negative 5 is included. So the bracket means if the integer is included as part of the solution. If not, you use parentheses. Okay? And then, union. That's the symbol for union. And then, the second part of the solution is from 2 going to positive infinity. And 2 is included. So I'm going to put again another bracket here. Then 2, comma, going to positive infinity. Parenthesis is for positive and negative infinity. Always use parenthesis, which means it's continuous. Okay? So let's have last one here. I have here x squared plus 10x plus 21 is less than or equal to 0. I'm going to replace this one with the equal sign. So that is the equation now. And I'm going to solve for the value of x by factoring. And the factored form is x plus 3 times x plus 7. This is 2 factors of 21 is 3 and 7. 3 times 7, 21. If I'm going to add this 3 plus 7, that is 10. So now I'm going to equate to 0 each factor, and that is solve for x. X is equal to negative 3 and x is equal to negative 7. Then I'm going to locate this numbers on the number line. That is where the negative 3 and negative 7. And then negative infinity and positive infinity. The original equation or inequality rather, x squared plus 10x plus 21 less than or equal to 0. So let's do the test point now. So let's have the first, second, and third part here. So we can choose any integers from negative 7 going to negative infinity. Let's choose negative 8. And then you're just going to substitute that negative 8 to x here. and here. So that is negative 8 squared plus 10 times negative 8 plus 21 less than or equal to 0. So 64 minus 80, because of this, plus 21 is less than or equal to 0. 64 minus 80, that is negative 16 plus 21 is less than or equal to 0. 5 is less than or equal to 0, which is false. On the second part, we have from negative 7 to negative 3. Let's choose negative 4. So negative 4 squared plus 10 times negative 4 plus 21 is less than or equal to 0. So instead of writing x here, you're going to replace by negative 4. Now, simplify. This is negative 4 squared, that is 16. And 10 times negative 4, that is 40, plus 21, less than or equal to 0. So this is now 16 minus 40, that is negative 24, plus 21 is less than or equal to 0. And negative 24 plus 21 is negative 3, less than or equal to 0, which is true. And for the last part here, we have negative 3 going to positive infinity, x is 0. That's the point that we're going to choose. Or any point actually, but this is what I have here. I choose 0, so that is 0, and this is also 0, so it's easy to manipulate. So what I have now is positive 21 less than or equal to 0, which is false. So this part, second part here, which is this one, is true, which means that this is the region where I can find, or this is the solution set. So again, I'm gonna put a shaded circle, which means that negative 7 and negative 3 are included in the solution set. Okay, that is the part. So the solution set now in interval notation is open bracket, negative 7. This open bracket means that negative 7 is included, comma, negative 3. And then I'm going to put another close bracket here because negative 3 is also included. So bracket if the integer or integers are included in the solution set. Parenthesis if not. So here you can identify it because of this equal sign here, which means that less than, greater than, parenthesis. Less than or equal or greater than or equal means bracket. Okay, so that's all for today, and thank you for watching, and see you on the next one. Please don't forget to subscribe to my channel and share my videos. Maybe I'm going to make another or second part of this, solving quadratic inequalities. See you on the next one. Bye-bye.